Welcome to the session. In this session, we are going to see what are the different techniques of aggregate planning. I'm Professor Adana, working as an assistant professor in the Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In this session, we're going to see what exactly are the different techniques of aggregate planning. Having understood the meaning of the word aggregate planning, where to be precise, aggregate planning means planning on the whole. We are not going down to the details of exactly how much material is required. We are planning everything put together. So how do we carry out this planning? What are the techniques? There are two generalized terms or two generalized categories into which the techniques with which we carry out aggregate planning fall into. These two major techniques are graphical and charting techniques and mathematical techniques. So going by their names, graphical and charting techniques involve plotting of diagrams, plotting of charts, plotting of graphs. These give us a very general description of exactly what the demand is going to look like, or whatever you're plotting. When you look at it, you can study the behavior of how it's going to be in future. So you have some sort of information, and what you're going to do is you are going to plot this on a graph. Depending on what you're plotting, you will be drawing information from this. With this inference, we carry out a plan. So the same for every other charting technique. So here you will come across different types of graphs, line graphs, and especially, very importantly, you will come across plots and histograms. So histograms are charts that look like bar graphs, but they're not exactly bar graphs. They give you the variations that you will see. For example, if I consider a range of 0 to 10, a histogram is going to tell you how many times different values go up and down within that range. So you will understand it better when we solve a problem. So here, when you're using a graphical or a charting technique, now there is no set rule that you need to do or plan or use only one kind of a technique for an aggregate plan. You can choose one among the two. Now, how do you choose this? This depends on you. This depends on the person who's carrying out the plan. The next kind of technique that we have is the mathematical technique. Here we use linear programming problems, linear decision making methods. So here generally we use mathematical techniques, and we convert the entire problem into a matrix or into a table and see what kind of mathematical model we can use. Here you either use a linear programming problem or you use any form of a technique called as operations research. Here you have various techniques, not just what you do in your basic mathematics. Okay, so when you are using any of these mathematical techniques, it is called an aggregate plan formed from a mathematical technique. Falling into these two categories, you need to understand what the guidelines are for you to formulate an aggregate planning problem or an aggregate plan. We are not just going to carry out a plan. You need to know exactly how you need to formulate this plan. The first thing that you need to do is determine the corporate policy. Each and every corporate, each and every company has its own guidelines and its own policies as known to you. You need to understand how these policies work. These policies will include how you can use resources, the availability of these resources. It could be man, material, money, anything. You need to first understand the policies of the organization. The next thing is you have to select a good forecasting technique. We have already, in the previous unit, you have already understood what forecasting is, and you have seen different techniques which are used for forecasting. Either you use a judgmental series, or you use a time series, or you can go for some other correlational series, that is something that is associated with a model. After that, you plan with appropriate units of capacity. This is very important because when you are carrying out the plan, you need to keep in mind that every organization, every institute, or every company that we are referring to here has its own limited capacity. It is not infinite. So the units that are available in terms of all the resources have to be kept in mind. You have to remember that you have to consider how much manpower is available, how many working hours are available for each person, what is the downtime of the machinery, all of those things for the entire duration and span of the production time. This has to be kept in mind. So you have to plan with appropriate units of capacity. The next thing is maintain a stable workforce. When an employee or when the number of employees in an organization are on roll, if they start to leave, it is called a process of attrition. And if the attrition meaning exit from the company, if the attrition level of employees is high, It just reflects bad management. It means to say that people who are working within the organization are not satisfied and hence they decide to leave the organization. Management should always work on maintaining a very stable workforce, especially in times where overtime might be required or when there is a new project coming in. We need to ensure that the workforce that is available on board is stable. Have a good inventory control. The management has to have very good control over the inventory that is available within the organization. Inventory now does not include only what's waiting in the showroom, only what's waiting to be prepared. It is inventory taking into stock of raw material, what is already in process, what is yet to be processed, what has been processed already and waiting for dispatch. Everything together, there should be very good control. Whatever aggregate plan you create, whatever aggregate plan you make, should be flexible to change. It should be able to respond to changes that occur in any business environment. There could be an economic drop, there could be some sort of calamity, there could be a fall. For example, now we are all living in the world in the state of the pandemic. Now this pandemic was unexpected. The companies that were not prepared for such a situation did not last too long. Those who were prepared were able to manage at least for a couple of more days before they had to make some other different strategy. So here, the plan that you make has to be very flexible to change. The plan should be able to respond to demand in a controlled manner. In a controlled manner meaning, once there is a change in demand, could be an increase or a decrease, the plan should not waver too much. All the reactions that the plan is going to give or all the changes that have to be made should be done with prior detailed study of the situation. Evaluate and check on a regular basis. This should be a system, that is a checking mechanism, should be a system that is inbuilt in the aggregate planning system. It should be incorporated into it so that from time to time on a regular basis, everything can be checked. The work levels can be checked, the inventory levels can be checked, and you can see whether the plan is working perfectly or not. So with these guidelines, which we have already gone through over here, we will now try to solve an aggregate plan. We will now try to make an aggregate plan, or rather formulate an aggregate plan to suit whatever requirements we have. The problem reads, a firm has developed the following forecast in units for an item which has a demand influenced by seasonal factors. A, prepare a table showing daily demand requirements. B, plot the demand as a histogram and as a cumulative requirement. C, determine the production rate required to meet the average demand and plot this as a dotted line on the graph. D, by graphical method, determine the minimum production rate when back orders are not permitted. So the tabular column is as shown here in the question. You have the months from January to December. You have the demand for each month and the production days for each month. So now that we've seen the problem and read the statement, we know that the demand that we are forecasting is depending on a season. So that means to say that at some parts of the year, the demand for this will be high and some parts it's going to be low. Also, the data that is given to us clearly shows this. If you observe the demand for this product, it is 220 in January, it is 378 in July, it is again reducing to 95 in November, again 260 in December, so it's varying. Okay, and the number of production days also is varying, where you can see that people are working for 22 production days totally, okay, in the month of Jan, and 18 in the month of Feb, 20 in the month of June, 21 in July, and so on. So you need to prepare, the first part of the problem tells you to prepare a cumulative table. Has asked you to prepare a table with cumulative demand and cumulative production days. The word cumulative means combination. So what we are going to do here is we are going to combine the number of days and prepare a separate table. The table that is given to you has the month, the demand and the production days. Here the demand that is there is the demand per month. You have been asked to prepare a table to show what is the demand per day. To this table, we will also add the cumulative production days and the cumulative demand forecast. So how do we do this? We will add to this table columns for the data that we need. We are adding 3 more columns, the demand per day, the cumulative production days and the cumulative demand forecast. These are the 3 extra columns that we will be adding to the existing table given to us. Okay, and we will start now by finding what is the demand per day. Obviously, if we know the total number of production days in a month and you know the demand in that month, so we are going to get what is the demand per day by dividing the value in column 2 by the value in column 3. So 220 divided by 22 will give us 10 days. Okay, we are dividing 220 by 22. You're going to get 10 days, which means to say the daily demand or the demand per day in the month of January is 10 units of the product. In a similar fashion, we will fill all the values from beginning to end. In a similar way, we will divide 90 by 18. The value is 5, 10, 18, 28, 35, 18, 10, 10, 5, 5 and 13. So I hope how we got all these values is clear. It is very simple. You're just going to divide the demand by the production days to get the daily demand. So every day, these many units of the product are required in the respective month. So the next step is to find out cumulative production days. So to find out the cumulative production days, in the month of January, we are just going to retain the number of production days because it is the beginning of production, 22 days as it is. How do I find out the cumulative production days that I've had in February? I need to club the production days of January as well as February. So if I add these two, I'm going to get 22 plus 18 giving me 40. Then I need to find out cumulative production days in the month of March. Add January, February, March, or simply 40 plus 21. It is 61. In a similar way, we fill the entire table. 105, 125, 146, 168, 188, then we have 211, 230, and finally we have 250. So here we have filled the cumulative production days as well. We have just added continuously the production days in each month. The last column is the cumulative demand. Again, it is similar to finding out the cumulative production. You need to add the demand consecutively. So you will add these two to get the cumulative demand forecast for the next month. Okay, so here when we add these two, you write it here. In the first month, it is 220 as it is. In the second month, it is 220 plus 90, which will give you 310. Then we keep filling the table. 520 plus 396, that gives you 916, 1532, 2232, 2610, 2830, 3036, 3145, 3240, and 3500. This is the cumulative demand forecast. So this is the table that we have prepared. What we're going to do now is, we're going to do a little bit of totaling. Why we're going to do this totaling? Because we're going to find out the average demand. For me to be able to find out the total average demand, the average demand for a particular unit or products, I need to find out the total demand and the total production days. So if I add the total demand, I'm going to get 3,500 units. That is the average demand. And if I add the total number of production days, I'm going to get about 250 days. Observe a similarity here. Cumulative production days all put together amounts to 250 days. It's the same over here. Okay? Cumulative demand forecast amounts to 3,500, which is the same over here. This does not mean that you can just draw the table and write the total. You will have to add these columns to it and show and verify that what you have done there is right by showing them these totals. Okay? So once we have got this, it is easy for us to find out average demand. The second part of the question, that is B, is the demand histogram. Now we need to plot this demand histogram as stated in the question as cumulative requirements. That means according to the cumulative production days. So you're going to plot the demand per day and the cumulative production days, taking them on the y and the x-axis respectively. So we know that for the divisions, we have to choose a suitable scale. The scale that I've chosen is on the x-axis, every centimeter or 1 centimeter is 20 days, cumulative production days, and on the y-axis, 1 centimeter, I have chosen it to be 5 units per day. Okay? Now each of these sections belong to the 12 months. So you have from January to December here. Okay? I haven't shown it on the graph, but it is understood that this is all the cumulative production days for all the months that are mentioned. Okay? So now what we will do is, we will plot the histogram as a cumulative requirement. We can see from the table that the cumulative production days for the month of January is 22, and the demand per day for the month of January is 10 units. So this we will plot as a histogram. Please note that the histogram is similar to a bar graph, and so the plotting is similar to that of a bar chart. So this is the demand for 10 units in the month of January. In a similar way, we will plot the demand for February, which is 5 units, and the number of days is 40. Five units for the month of February. Again, from the table we can see the month of March. March, again, the demand is 10 units, similar to January, and the number of days of production in the month of March is 61 days. Units for the month of March. Further, moving on, April. The demand for the month of April is 18 units. 18 units. And the number of production days is 83 days. So we plot the demand of 18 units. We plot the demand of 18 units for the month of April. For the month of April. May has a demand of 28 units. And number of working days as 105 days. This is for the month of May. The month of June has a demand of 35 units, and the number of working days is 125. So here this is a total of 35 units for the month of June. The month of July has a demand of 18 units and 146 working days. 18 units and 146 working days. This is for the month of July. August has a demand of 10 units and the number of working days is 168. For the month of August. September has a demand of 10 units as well and 188 working days. So this is the way you plot the histogram. 188 working days for the month of September. Coming to October, we have 5 units in demand and 211 working days. 5 units in demand and 211 working days. In a similar way, for November, we have 5 units in demand, 230 working days cumulative, and for December, we have 13 units. For December, we have 13 units in demand. And cumulatively, we would have worked for 250 working days. So this is the demand histogram for the product that we are referring to. So the next part of the question states that we need to find out the average demand and plot it as a dotted line on the graph. So what is this average demand? Average demand is the total demand divided by the total number of production days. 3,500 is the total demand that we got from the table and 250 is the total number of production days which we got from the table. This will give us about 14 units per day. 14 units per day, which means to say that on an average, the demand per day for this product is about 14 units. Plot this as a dotted line on the graph, which means we have to plot so this line indicates the average demand of almost 14 units per day. So we have plotted the histogram, we have found out the average demand, which is 14 units per day. We have plotted that as a dotted line on the histogram. The next part of the question states that you need to plot the cumulative graph for the demand and the production days, and here you have to determine what happens if there is no back ordering. That means you use the graphical method to understand exactly what is the production rate when we don't have a back order. What do we mean by a back order? A back order is a pending order. For example, if somebody has placed an order this month and the person has not been able to receive the products because we have run out of stock of the products, then we have a back order, which means a pending order which has to be fulfilled later. Okay? So in such a case, we have to plot the demand graph. Here on the x-axis we take the cumulative production days and on the y-axis we consider the cumulative demand in units. So here we are going to plot it just like a regular graph. taking a suitable scale. I have considered x-axis 1 centimeter equal to 20 days, and on the y-axis I have taken the cumulative demand in units, 1 centimeter equal to 500 units. Now these scales and units are all dependent on you. Whatever is the convenient scale that you want to take on your graph sheet, you can consider it. Okay, so here we will start by plotting the graph. So the demand in the first month, so we know that the values are, for January we have about 10. So I'm just going to be plotting it very randomly, because you can see I don't have a real graph sheet, so it is a very random scale. So when you're plotting this graph, please try to use an actual graph sheet and draw it to scale, so you'll be able to get the values in a more clearer fashion and more accurately. So in the first month, we observe that it is 220 units for 22 days. Second month, it is going up to 310. The third month, it is about 520 units. The fourth month, it is about 916 units. The fifth month, it is 1,532 units. The seventh month, it is 2,232 units. So please note, on the x-axis, the number of days that we're taking is the cumulative production days, 2,232 units. Then it goes up to 2,600 units. $2,830 units. $3,030 units. $3,145 units. 3,240 units. It is going up to 3,030 units. $3,145, very close to each other. 3,240 units. And finally, 3,500 units. So like I mentioned earlier, please choose a suitable scale according to your graph sheet and size of the sheet that you're using, and then plot the graph. Now what we're going to do is we're going to use a free line, curved line, that is not a straight line. We're just going to draw a curve joining all these points as we do in graphs. So a free form line that will give you the behavior of the cumulative demand. The next thing that we're going to do is we are going to see what is going to happen if we join, or rather if the production happens as a straight line. That is inventory surplus, no inventory surplus, we are not looking at that. I'm going to join the origin, that is the beginning of the production days, to the end of the production days with one straight line. We'll represent it as a dotted line. So this line represents the average production that we need to achieve. The average production line. So I'll just call this line A. It is the average production line. How do we get this line? Just join the first and the last. Now, average production line, this gives us 14 units per day. We already found out the average production number of units. The question states that if no back ordering is allowed, what will be the rate of production? Certain things you need to understand from this graph. Wherever this line is crossed, so here we have inventory surplus, extra inventory. What this means is, this is the production line, right? So beyond this, whatever production, beyond this is the average production line. So once this has been produced, we have reached our demand. Whatever production surplus inventory is remaining is here as the curve. Okay, so we have some surplus here. Here also we have some inventory surplus. Here also we have some inventory. Okay, now what we will do is, taking a line starting from the origin to the highest point of the demand curve, what we're going to do is we're going to draw another dotted line. So what we're trying to say here, this is the maximum production line. There are no pending orders here. There are no pending orders. What we are trying to say is, this is the average production line. There is nothing pending, so the highest demand has also been met. This is the, we will consider this to be line B. Line B. This will be the production rate with no back orders. Meaning, highest level of demand has been met and there is nothing remaining. Suppose they had said there was a number of back orders that were given to you, the number would have been given to you. Based on that number here, you would have to draw this line. Then we would see how much we would be having for production rate. Now, how do we find out the production rate at this point? We know that the maximum demand that we have here, cumulative demand, is 3,500. So just draw. Find the slope of this line. How do you do that? From 3,500, just draw a horizontal line to a point where it meets this line, the line that we're referring to. Okay? At this point, you drop horizontal line to a point where it meets this line. Okay, so at the point where it meets, you drop a perpendicular downwards to the x-axis and see where it meets. So this, if I assume it to be, say, 179 days, okay, it's just an assumption because this is not a drawing drawn to scale. Then you can say that if at all there are no back orders, the production rate is equal to the total demand that we have with no back orders. Looking at this graph, I'm getting 179. Please note, this is a value that you get from the graph. It's about 19.5. It's about 19.5 units per day. This is a value you get from the graph. So slope of line B will give me production rate. So here you can also write this as the slope of line B. Another thing that you can do, you can also extend or find the slope of the same line, in a similar way, slope of line A, and see where it meets. Does it meet 250? Okay, so when you draw it to scale, it actually does. It actually meets 250 days. Okay, so this is how you find out the production rate using the graph.